Assalamu alaikum. I am Abdullah Mamun. My ID is 2006069. I am from Group On. The title of our project is Enhanced Smart Helmet for Rider Safety and Accident Alerts. Here is our outline slide. First we discuss about summary, then introduction, then design, then we show our implementation of our design, then analysis, then evaluation, then reference. Here is our summary. So our project is mainly Arduino-based project, where we detect wire, which prevents vehicle ignition if helmet is not on. Alcohol detection MQ3 sensor detects alcohol in rider's breath. Crash detection. Accelerometer senses sudden impact or fall. RF communication sends signals from helmet to vehicle unit. Alert mechanism uses LEDs and buzzers to notify warnings, sends SMS to family members. Safety actions triggers alerts or disables ignition in unsafe cases. Cost effective, affordable and accessible for riders and developers. Beginner friendly, easy to build with basic electronics knowledge. Here is our introduction. The smart helmet ensures safety by detecting whether the helmet is on. It uses an MQ3 sensor to detect alcohol and accelerometer to sense crashes. The system wirelessly communicates with the vehicle using RF modules. It can disable ignition if alcohol is detected, preventing unsafe riding. This system helps reduce accidents by tackling helmet misuse and drunk driving and crash impacts. Here is our problem formulation, which is our project outcome B. Identification of scope. Motorbike accidents are serious safety issue in Bangladesh. A key reason is reckless driving and the lack of proper safety measures. Many riders do not wear helmet due to weak enforcement. Crash victims often don't receive quick help because there is no automatic system. This highlights the need for a smart helmet that improves safety and speeds up emergency response. Okay.
Assalamu alaikum. This is Sheikh Tariful Islam, ID 2006066. So I will actually talk about the literature review. We know that this system integrates multiple safety features into one single affordable helmet with a focus on alcohol detection, crash detection, and wire detection. So let's dive on the details. The wire detection can be done in different ways. The Mohan and Chan showed the two good ways, but we think that we can reduce the cost, so we actually did it with the voltage supply. Very simple, very easy, and it is less costly. Next, we dive into the alcohol detection, the first critical feature of this project. One of our primary cause of motorcycle accident is riding under the influence. Our system addresses this by continuously monitoring the rider's breath control level using the MQ3 sensor. As demonstrated by Bharat et al. In 2019, the MQ3 sensor is effective in real-time alcohol detection and is widely used in low-cost embedded system. Additionally, Patel et al. In 2020 reviewed the advanced breath analysis system using IR spectroscopy for even higher accuracy. This system ensures that only sober riders are on the road, helping to reduce alcohol-related accidents. So we actually took the MQ3 sensor because in the real time we saw that it works absolutely fine other than IR spectroscopy, and it is less costly. Next, we will talk about the crash detection, a key feature in rider safety. In the event of sudden impact or accident, our system will trigger alerts to notify emergency contacts. We use accelerometer-based detection as outlined by Khan et al. In 2017, where MEMS accelerometer detect high-impact collision and send immediate alerts. To improve accuracy, Zhao et al. In 2018 proposed integrating accelerometer with other sensors like gyroscope and pressure sensors. This approach provides nuanced feedback about the crash severity, ensuring timely and appropriate responses. So we actually did it with the accelerometer and gyroscope and saw that it has a great outcome. By combining these safety features, alcohol detection, crash detection, and wear detection into one system, we create a comprehensive safety solution. Ghosh et al. In 2020 demonstrated this design of a multi-sensor helmet that not only detects wear and alcohol presence but also disables the vehicle ignition, from which we actually took the idea about the relay system by which we can actually stop the bike to be started if there is no helmet wear. Furthermore, Srinivas et al. In 2019 developed an IoT-enabled helmet that transmits data to a mobile application for real monitoring and alerts. The integration of these technologies allows us to address multiple risks at once and improve overall efficiency. As the mobile app is actually not that efficient about on the emergency context, so we actually did it by a GPS module from which we will take the location and it send it by a GSM module via a message or a call, so that emergency contact can be notified in that exact moment. So, however, despite these advancements, there are gaps that still need to be addressed. Firstly, cost remains a significant barrier. Advanced sensors used for detection increase manufacturing expenses, limiting the affordability of such systems. Secondly, many current systems lack real-time feedback, which is crucial for providing immediate alerts to riders and emergency services. Lastly, accuracy in dynamic environments such as varying weather condition or non-standard riding behavior can affect sensor performance. These challenges highlight the need for further research and development in this field. Our smart helmet system is analyzed based on functionality, sensor selection, and integration. The goal is to deliver a cost-effective, robust, and responsive safety solution. The key focus is ensuring that the helmet performs accurately under real-world conditions, including providing real-time communication between the helmet and the vehicle. Despite the challenges, we are confident that with the right combination of low cost, reliable sensor, and effective integration, this system can greatly improve rider safety. The design of the helmet is driven by three key requirements. First one, detect helmet wear, alcohol presence, and crash events, and then enable real-time RF communication with the vehicle for alerts and data transmission, and lastly, ensure low power consumption, comfort, and affordability for long-term usage. These requirements guide our selection of components and the overall system architecture. Thank you, everyone.
Assalamu alaikum. My name is Ilyas Ahmad, ID 68. So let's discuss about the design method of our project. After reviewing different paper, we finally found a suitable component to build our project. For wire detection, we want to use a transmitter circuit. When transmitter circuit power is on, then a status signal sent from the transmitter circuit to the receiver circuit, and receiver circuit is detected that transmitter circuit is on. Actually, this is used to simulate that the helmet is on or not. Then for alcohol detection, we want to use MQ3 gas sensor. For crash detection, we want to use accelerometer MPU 6050. For communication, we want to use RF transmitter and receiver module of 433 megahertz. For processing all the data from different sensor, we want to use Arduino Uno as our microcontroller. And for SMS or alert, we are using GSM 900A SIM module. Then for location detection, we want to use Ubox Neo 6M. And for power supply, we are using LiPo battery. For transmitter circuit and receiver circuit, we are using different LiPo battery. And in our transmitter circuit, we have different current requirement because our microcontroller and the sensor has low power requirement, but the GSM 900A module have higher current requirement. So we need to use two different battery to meet those current requirement. And for showing status in our receiver circuit, we want to use I2C LCD display. And for other purposes like giving different alert, we are using LED and buzzer. And for turn off and turn on our circuit, we are using different switch. Now let's discuss about the hardware setup of our project. In transmitter circuit, we are using MQ3 sensor and accelerometer as our sensor, and those sensor data are collected by Arduino Uno, and those data is also processed by Arduino Uno, and then through RF transmitter, those data are sent to receiver module. And in receiver module, this processed data are decoded, and based on the status, it's turn on or turn off the motor by a relay. This relay turn off and turn on basically represent the bike turn on and turn off. And for showing status, we are using a I2C display, and giving for showing alert, we are using LED and buzzer. Let's discuss about the software and algorithm of our project. In transmitter circuit, we are detecting that the helmet is on or not, the alcohol is present or not, the crash is detected or not. If a person is not on the helmet, then in receiver circuit, he or she can't able to turn on the bike through relay module. And if a person is detected with alcohol, then the transmitter circuit send the signal, and receiver circuit can't allow the bike to turn on. And if a crash is detected, the transmitter circuit send the signal to turn off the receiver circuit. It's actually simulate the bike turn off, and also the real-time location of the crash is sent by SMS. So let's discuss a little bit about the crash detection algorithm. We are using MPU6050 accelerometer for detecting different 3-axis acceleration, and those acceleration magnitude is calculated. Here actually ASQRT is missing. Little bit correction, and we are using a threshold, and then we calculate a delta for minusing 1 from our acceleration magnitude, and then we compare the delta with impact threshold. In our code, we set impact threshold 1.5, and based on this, if a crash is detected, then it's set the status crash status to true, and send a signal to receiver circuit to turn off the bike, and also it send the real-time location by SMS, and if not, it's continuously monitor the system. Then let's discuss about the integration and testing of our project. We assemble the transmitter and receiver unit together, and here some of our data are analog, so we need to use moving average filter for get more accurate data, and we are also use debouncing to get accurate data, and for avoiding any unwanted data. Then we need to adjust threshold and tune the threshold of our different analog sensors, and also we need to stabilize the RF communication, and also we try to optimize our system as much as possible to get to get a longer battery life. And we also implement real-time monitoring through I2C display. Let's discuss little bit about the circuit diagram of our project. Here we can see the final transmitter circuit diagram. Here the central Arduino Uno microcontroller and all the sensor are integrated to it, and this is basically the RF transmitter module. And to power off all this module, we are using a battery here. And this is the final circuit diagram of our receiver circuit. Here we are using another battery to power up this circuit, and this is basically the relay. It's actually turn off or turn on the motor. It's actually represent the bike is turn off or not. And here is the microcontroller. Here I2C display to showing all the status. And here is the buzzer and LED to show the status. And this is the RF receiver module to get the signal. So this is all for me. Next part is discussed by my another teammate.
Assalamualaikum, ID 2006067. This image shows the physical implementation of the transmitter circuit within the helmet, showcasing the Arduino breadboard, battery, GSM module, and various wires. This image displays the physical setup of receiver circuit, including the Arduino LCD, breadboard, battery, and DC motor. This slide indicates the section for the project demonstration. This slide lists of aspects of our design, analysis, and evaluation. Discussing the novelty of our project, multi-feature integration. It combines wire detection, alcohol detection, and crash detection in one helmet. Immediate safety response, triggering alerts and disable vehicle ignition during unsafe condition. Wireless connection sends helmet status to the vehicle system via RF modules. Design here our design consideration, public health and safety. Our systems ensure the helmet is worn properly to reduce head injuries, disable the vehicle if alcohol is detected, send crash alert for faster emergency response, and promote safety compliance to reduce injury related facilities. Cultural and societal consideration, the system encourages helmet use in culture with low compliance feature and affordable design, suitable for low income riders, address alcohol related societal issues, is easy to use with LED buzzer indicator, and enhance safety while fostering responsible rider behavior. We also acknowledge the limitation of the tool we use. GSM 900A module can face network issue dealing message delivery. Accelerometer may not effectively detect rotational or low intensity crash and requires careful sensitivity calibration. GPS module can have network issue and may not detect location in closed space. Our impact assessment covers several key points: societal and cultural issues, health and safety issues, and legal issues. These slides outline the individual contribution of each team member to various tasks. All members participate in group discussion, gaining software knowledge, theory knowledge, PPT preparation, and report writing. Specific tasks like hardware setup, wire detection, crash detection, alcohol detection, and GSM, GPS module integration and had varying participation among the members. Here our logbook of our project. This slide represents our project management and cost analysis. We have detailed the current cost and potential bulk cost for each component, showing a total current cost of 4717 taka and a bulk cost of 3448 taka for component like MQ3 sensor, MPU 6050 etc. Looking ahead, our future direction include enhanced feature accuracy, integration with mobile application, machine learning integration, extend battery life, regulatory compliance and standardization, global accessibility and affordability, integration with vehicle system. Thank you, sir.
So hello everyone, this is Sheikh Tariful Islam again. Now let me walk through you how our course outcomes COs are mapped to the program outcomes POs, which help us ensure that our academic efforts are aligned with broader educational objectives. As you can see in the table, different COs are linked to specific POs based on the skills and competencies demonstrated in our project. For example, CO2 maps to PO3, where we focused on the practical implementation of the project. CO4 maps to PO6 and PO7, highlighting our attention to safety, societal impact, and sustainability. This mapping ensures that each course objective is aligned with essential program outcomes that reflects professional and technical growth. Now let's break down what each of this mapping really mean. CU4 to PU7 focuses on the sustainability and social impact of our work, ensuring that our project doesn't just solve a technical problem but also contributes positively to the environment and society. CO2 to PO3 is about the practical demonstration. We have shown how our solution meets specific technical requirements. CO4 to PO6 covers necessary modification made to address health, safety, and environmental concerns during project development. CO5 to PO9 reflects the multidisciplinary aspects we addressed, integrating knowledge from various domains. CO7 to PO11 looks into how we applied engineering management principles and economic decision making, a critical aspect of any real world project. CO6 to PO10 is about communication, where we used multimedia tools, project reports, and manual to effectively explain our work. This detailed mapping proves how each learning outcome is meaningfully connected to professional development. Lastly, this project also touches on key knowledge profiles defined under Washington Accord. K5 relates to how we applied engineering knowledge in a specific practical area. K6 covers our application of technological know-how in real-world engineering scenarios. K7 shows our understanding of engineering broader impact on society, including ethics, public safety, sustainability, and cultural context. Together, this mapping validates that our work is not just technically sound but also socially responsible and professionally relevant. So this is our necessary reference we took for our project. Thank you everyone.